Good evening, stargazers. My name is Joe Grida. I'm the Technical Information Officer for the Astronomical Society of South Australia, and welcome to the sky this month for July 2021. And what a cold month it's been so far. Let's draw the curtains and reveal our sky for July. And this all sky chart, west is on our right hand side, east on our left. As you can see here, the constellations of Hydra and Virgo are slowly setting off into the west, and they are replaced high in the sky by our winter constellations of Scorpius, Pavo here in the south, Sagittarius, Ophiuchus, Aquila over in the northern sky there, and very low in the north to northeast sky we've got the bright star Vega. Arcturus is over in the northwest, and over in the southern sky, the Southern Cross has started to make its downward slide towards the southern horizon. The pointers, Alpha and Beta Centauri, are still higher up in the sky, always pointing towards it. And low in the southern sky, we've got the Large Magellanic Cloud, which, if you're out in the country on a clear night, you'll be able to see it quite clearly. Higher up, the Small Magellanic Cloud and the beautiful globular cluster 47 Tucani, or NGC 104. Right next to it. Bright star Echina, low in the south-southeast. I always use Echina and Alpha Crucius over here in the Southern Cross. Join those two together, and just less than halfway from Acrux to Echina, you've got the South Celestial Pole. Further in the southeast, rising later in the evening, we've got Grus, the Crane, in the south. Beautiful galaxies hidden inside that constellation, and of course Aquarius is rising in the east, bringing Jupiter with it. Can't miss it. You go outside, look east, and there's no way in the world that you can miss bright Jupiter. Brightest object in the late evening sky at the moment. And a little bit higher from it is the beautiful ringed planet Saturn, visible in Capricornus as well. And as we move over towards the northeast, we got Altair, the brightest star in Aquila, the eagle over here, and the beak of Cygnus, the swan, is just starting to appear. We'll talk about that next month, as well as Alberio, the beautiful double star just over here. So that's our July evening sky. Very early in the evening, you'd see a Venus in the low in the western sky, and we'll talk about that very shortly. But first of all, let's go and have a look and see what the moon is doing. So for the first half of the month, we basically have no moon in the evening sky, as it's rising around about midnight and later. So right until the 15th of July, right through the mid-month, before it starts to interfere again in the evening sky with the waxing crescent. So first half of the month is deep sky evening viewing, and the second half of the month you might as well enjoy some of the vistas available to you by looking at the moon, or perhaps you might like to concentrate on some double stars, like one of the ones that we're going to be talking about later in this program. All right, our lunar feature of the month, and I went through all the other programs I've done, and I was surprised that I'd not covered the crater Clavius, very low and towards the lunar south pole. We see it quite foreshortened. The red arrow here points at where it is in relation to a full moon, just below the very bright Tycho crater with its gorgeous rays. Again, another crater that I haven't talked about, so we might reserve that one for next month. But here's Clavius over here, and an expanded section of that part of the moon shows the big crater Clavius just over here, where the red arrow is pointing to the middle of it. All right, let's talk a little bit about Clavius. It only looks oval-shaped like that because of the foreshortening that we get as we're looking around the limb of the moon. It's actually a proper round crater, 225 kilometers in diameter. It's actually named after Christoph Clow, a German astronomer and mathematician. Back in 2020, astronomers observing using a telescope aboard the Sophia, NASA's Sophia Boeing 747 flying observatory, were able to observe molecules of water trapped in glass within the confines of the crater Clavius. And you can see here in the middle of the crater this sort of crescent-shaped line of craters getting smaller and smaller as we head along from D to C to N and then on to J, and all the other little craters strewn across the crater floor. I've certainly used it as a great way of judging what the observing conditions are like on any particular evening. So you can really test how good your telescope and how good the seeing is on any particular night. Of interest around the crater, we've got this big one here called Blancanus, 105 kilometers in diameter. It just gives you an idea of the size of objects that we're looking at. Rutherford crater over here, 54 kilometers in diameter, named after Lewis Rutherford. He was an American astronomer who helped develop solar and lunar photography, and here's an example of one of his earliest lunar photographs there. Wouldn't he be amazed as to what we can do today with our CCD cameras? Handsome fellow, wasn't he? And another famous gentleman is immortalized here in Porter crater. This crater is named after Russell W. Porter, the architect, artist, and amateur telescope maker, who also designed the 5-meter telescope on Palomar Mountain, probably the most famous of all the observatories in the world for a long time. And he also wrote the amateur telescope making books, which in the 40s, 50s, 60s, and 70s were the absolute Bible for amateur telescope makers. And I very proudly go and grab those books out of my bookshelf on a regular basis and leaf through it and reminisce about the days when I used to grind mirrors and make telescopes. And the whiff of those pages takes me straight back. Here's a picture of Russell and the 200-inch telescope at Palomar Mountain that he designed. All right, the planets for July start on the left with the inner solar system. You can see the locations of the planets in their orbits in relation to Earth. Here's why when you look in the evening sky, you'll see Venus and Mars relatively close together in the sky, because that's where they are, right across the other side of the sun from us, and we can see them quite clearly. And Mercury in the morning sky. As we look out towards the outer solar system. Again, Jupiter and Saturn, as my pointer. Jupiter and Saturn are fairly close in the sky as well. Neptune is rising very late in the evening, and Pluto is in Capricornus as well. Right, in just a couple of days' time, hopefully you do get a clear late or early evening, soon after sunset, and you'll be able to see Venus meet up with the Beehive star cluster in Cancer. You remember last month that the planet Mars actually glided past the Beehive only about 2 weeks or so ago. And now it's Venus's turn to do that. So have a look low in the western sky. That looks like to be about an hour after sunset, and you'll be able to see Venus as it glides past the Beehive star cluster here. Should be a nice view in binoculars. You won't see as many stars of the Beehive as you could last month when Mars was passing by them, because Venus is so bright that it'll actually wash out some of those stars. Hop to the early morning sky, and I remember watching Orion low in the western sky soon after sunset, not that long ago, and it's already climbing up the eastern pre-dawn sky. And right over in the northeast, you'll be able to see the moon, and you can find little planet Mercury not far away to its right. There's a bit of a close up. So you've got very thin crescent moon there very early in the morning, just before it goes to new. There's Mercury. Great way to locate both of them. If you find Mercury, look over to the left, and hopefully you see a very thin crescent moon. And if you do happen to have your telescope out that morning, have a look at the Crab Nebula just over here. Back to the evening sky on the 12th of July. Again, soon after sunset, you'll be able to catch the very thin crescent moon with Venus and Mars as well. That's the head of Leo the Lion just over here. Here's a bit of a close up. You can see again how thin the crescent moon will be. So this would be a great chance for you to have a look at a very young moon along with Venus and Mars. And lastly, on the 22nd of July, again in the western sky, you can see that Venus has now passed Mars, is rising higher in the sky, makes a nice big wide double with Alpha Leo or Regulus in the sky there, and Mars a bit lower. These are all great binocular sights for you, so do get out there and enjoy it if the weather allows you to. There's a bit of a close-up of that. Right, later on in the evening sky, as I mentioned earlier, we've got Saturn over here, the red arrow pointing straight to Saturn, and this other red arrow here pointing to Jupiter in the northeastern sky. This is at 9:22 on the 15th of July, so halfway in the month. So by 9:30, you'll see that Saturn is probably around about 30 degrees up the sky, and Jupiter probably getting close to 13 degrees or so. So let's have a look at Saturn first. Saturn obviously is the beautiful planet with the rings, and whilst I was preparing this, I thought to myself, gee, the rings are getting tighter, starting to close up on us, and I thought this might just show you how the rings are changing. The angle at which we view those rings is changing. This is when they were at their widest in 2017, and in 2021 you can see that they've closed up a bit, and by 2025, in another 4 years' time, from memory this was March 2025, you can see how thin the rings are. So get your fill of the rings in the next couple of years before they become too edge on, and then we lose them for a year or so until they start to open up again. But looking at Saturn, always look for the Cassini division, one of these major divisions in the rings, which is visible even with on a good steady night, even with a small telescope, and you'll always pick up 4 or 5 of its retinue of around about 70 odd moons. As I said earlier, Jupiter is lower in the sky, so you might want to wait. By the time that you've had your fill of Saturn, Jupiter will have risen a little bit higher in the sky, so atmospheric interference won't be too much, and you should be able to start to see some of the cloud belts of Jupiter, as well as its moons. You can actually watch the position of some of these moons, especially Io and Europa, who are orbiting much closer to Jupiter. You can see them change their position within 15 minutes to half an hour or so, and sometimes you'll see any of these moons crossing or transiting the face of the planet as well. It's always something interesting to be looking at on Jupiter. And just this year, for the beginning around about March and ending around about October, November, we crossed the plane of the orbits of the satellites of Jupiter, where we can actually see the satellites themselves pass in front or behind each other, as is shown in this little diagram here, where you're watching the light of one moon disappearing as it passes behind one of the other moons. This happens every 6 years or so. So we can see occultations where one moon passes in front of the other, or you can watch the shadow of one of the moons eclipse the other one. If you want more information and get timings for your location as to how to see these events, here's a website that you can go to get that detail. Our double star of the month this month is Beta Muscae. Very easy to find. This is a Southern Cross here, so in the southern sky, basically at the end of the long arm of the cross, just past Alpha Crucis, you find Musca the fly just here, and this out of shape rectangle is basically the body of the fly. That's Alpha Muscae here, and there's Beta over here. Very, very easy to find. Quite pretty in a telescope. You'll need around about 150 times or so to split them properly, because they are separated only by 1.6 arc seconds. So you want nice viewing conditions and a reasonably high magnification to separate them. They're both white stars, almost equal in magnitude at 3.6 and 4.1. They're both the spectral classification of B2, which means they're quite young stars, bluish white. And because they're young, the estimated age of them is only 15 million years, compared to our sun at the moment. It's a middle-aged star of about 4.5 billion years. So these are really young pups. You can see from the orbit diagram here that the way that we see these two stars, they display a very elliptical orbit. Probably greatest separation will occur around about sometime between 2150 and 2200. I think I'll be around to be able to witness that, and they're about here now, around 1.6 arc seconds. It'll probably go out to at maximum separation of around about 2 arc seconds. But shouldn't be too difficult to see in a 6-inch or larger reflector, or a 3-4-inch refractor. But as I say, make sure you use a high enough magnification to separate them. My recommendation would be around about 150 times, and they're 340 light years away. Give you a different slant on the location in the sky here. So here's our Southern Cross, just there. There's Acrux and there's Beta Muscae, just there. Very easy to find. Shining at a magnitude of about 3, so it shouldn't be too difficult to find even from a light polluted sky. And whilst we are in Musca, I thought we might as well visit a couple of its deep sky glossies. The 2 globular clusters, NGC 4833 and NGC 4372. Both of these objects were photographed by Daniel Verschuer from Chile, and using exactly the same telescope, exactly the same equipment. So you can see how different they look through the eyepiece. Obviously, you won't see that many stars. He's captured far more in these images than you'd ever see visually. But this one here, 4833, is quite compact. It's only 4 minutes in diameter. So it really looks, especially if you say using binoculars, it'll look like a faint comet in the sky. A 6-inch or greater telescope will start to show quite a nice view of this cluster. You can see how compact it is. It's quite condensed. Whereas when we look at 4372, this is much larger. Compare the 4 minutes to 18 minutes in diameter. Visually in a telescope, this looks quite sparse. You don't see all these tiny stars that you see resolved in this long exposure photograph. So you might even be forgiven to thinking you're not looking at the right object. You think it's an open cluster, but it is actually a globular cluster. And use this star as your guidepost. You'll know that you're looking at the right object. If you this is around about a 5th or 6th magnitude star, quite easy to see, and stands out quite a lot in that field. But yeah, don't be surprised if you think that you're not looking at a globular cluster. And there's Beta Muscae right here, where we've just been visiting that double star, and move over to the other side of the body of the fly. And on one end is 4833, and on the other is NGC 4372 over here. So not all that difficult to see. As always, recommend that you download your Stellarium planetarium software. This is what I've used throughout all of my presentations to generate those sky fields. So download it. It's free for you. Use it to make yourself acquainted with the night sky. And as always, thank you for watching this presentation. You can email me your questions at technical@assa.org.au. I'll be happy to get a query from you and happily answer it. And you can get the latest information about activities with the Astronomical Society either by visiting our website or subscribe to our YouTube channel, where you can watch this program and many others from the Astronomical Society. Always find us on Facebook as well for any last minute details of activities. Instagram for images that our members have produced, and you can also follow us on Twitter as well. Thank you for listening, and happy stargazing.